like to talk a little bit about composite functions. You maybe have seen these before. You sometimes will hear them called function compositions. It's the same idea. So a composite function is a function that is written as, we write it as f of g of x. It's written like that. You also will see it written as f of g of x like this. So either of those two ways are perfectly acceptable. These are really, really important for calculus. You see them all the time. So it's a good idea to make sure you understand a lot of it now. So let's do some examples. So if you've done this before, you're welcome to go ahead and try these on your own. Otherwise, I'm just going to do the first two, and then I'll probably have you actually try 3 and 4 on your own. So for number 1, the first thing that we're going to do is rewrite this as f of g of -1. It's always a lot easier to look at it like this. So we're going to find our first, what's on the inside, the g of -1. Remember, you're just going to substitute in -1 for this function. That gives you -2. So then we do f of -2, which is 3 of -2 squared plus 2. That gives us 3 times 4, which is 12 plus 2. And my answer for that one is 14. Number 2 is pretty similar, except that we are going to compose f with itself. So we have f of -1. First step is always to rewrite it. So you can find f of -1 by substituting -1 into that f equation. When you do that, you get 3 times +1 plus 2, or 5. Now I'm going to substitute 5 into that equation. Number's a little bit bigger, but it's not completely terrible. We end up getting 77 for this one. Go ahead, please pause and try the next two on your own. So for number 3, same idea. We are going to do g of f of 2. F of 2 is 14. We do g of 14. That gives us 2 times 14, which is 28. And then g of 8, we are going to rewrite that as g of 8. G of 8 we know is 16. You just plug in the 8 for x. Then we do g of 16, which gives us 2 times 16, or 32. For the next type of problem, this actually is really useful if you are taking AP Calculus next year. They love this type of problem on the AP exam. If you're not taking AP Calculus, there's still a really good chance you'll see it in college. You will probably see something like this in calculus. So we are going to use the table to find compositions of functions. So let's do 5 and 6 together, and then I'm going to have you do 7 on your own. So for number 5, we are going to start by rewriting this as f of g of 2. And what you're going to look at in the table is you want to look in the column where x equals 2. You want to see what the value of g for that one is. And it is going to be 1. So the stuff in the parentheses is now going to just be 1. Then you're going to do f of 1. And you'll notice that we have this column where x equals 1. F of 1 is going to be 4. So that's my answer for that one. Feel free to pause and try 6 and 7 on your own, or you can watch me do 6 and then pause and try 7. So number 6, we are going to start by rewriting it as g of 1. And when x equals 1, I end up getting that my g is 3. So now I'm going to do g of 3. When x equals 3, g of 3 is going to be 4 again. Then for number 7, again, if you didn't pause before, you can try now. We have g of f of 0. F of 0 is going to be 3. You can find that by looking in the table when x equals 0. g of 3 is 4 again. It actually is just a coincidence that we got 4 for all three of them. I didn't do that intentionally, but sometimes that happens. So this next example, this is actually our last example, is going to be really useful in the next section when you are looking at inverse functions. So we would like to show that f of g of x and g of f of x are equal and that they both equal x. So I'm going to start by figuring out what f of g of x is. By the way, if they ask you to show that something is true, you can usually assume that the thing that you're supposed to show actually is true, unless the problem was written incorrectly. So we'll start by f of g of x, and I'm going to go ahead and write that all out. This one we don't have any numbers, so unfortunately it's going to be a little bit longer. So I write this as f of x plus 3 over 5. So I put my g of x into the g of x place. This is my g of x. Now I'm going to substitute this entire thing into that f equation for the x. So I get 5 of x plus 3 over 5. Do not forget that minus 3 at the end. Basically what I did here was I just took my, what I knew was f of x. I knew f of x was at 5x minus 3. I plugged in the x plus 3 over 5 to x. So now I'm going to simplify this out. When I simplify that, actually I have 5. There's a few ways that you can write this. You might be able to get by skipping this middle step. I'm going to rewrite it like this so that you can kind of see that the 5s are going to cancel out. You wouldn't be able to do that if the 5 was just multiplied by the x only, but since it's multiplied by the entire x plus 3 factor, you're allowed to cancel out the 5. So I end up with x plus 3 minus 3, and that's equal to x. So I'm off to a good start. That's what I would like to start with. If I got something other than x, then I would probably have to go back and check my work, make sure I didn't make any mistakes. Now I'm going to do the same thing with g of f of x. You're welcome to pause the video and try it on your own. So I'm going to rewrite g of f of x like this. And I'm going to substitute in for this f of x, I'm going to substitute in 5x minus 3. Now I put that into the g equation. So I have x plus 3 over 5. In for that x there, I substitute in 5x minus 3. Then I add the plus 3 and I put it over 5. From there, I'm going to simplify everything I can. I get 5x minus 3 plus 3 is 0, so I just have 5x over 5, which simplifies to x. So I do think it's a good idea to end with like therefore. Whatever you started with, that's a good practice to have in math. If you are a bit lazy, there is a shorthand way to write therefore that we use in math. You can use this. And it's just going to be 3 little dots in a triangle. That means therefore in math. It's if you're proving something that you can just restate what you're proving. So we have therefore f of g of x is equal to g of f of x is equal to x. We have one other type of problem. So what we're doing in this one is we are finding functions of f and g such that their composition equals an h, and our function h is 3x plus 2 to the 6th power. So basically what this is saying is that f of g of x is equal to 3x plus 2 to the 6th. So you'll notice that g of x is our inside function, f of x is our outside function. So g of x, you'll have several possible answers for this, but I'm going to give you the most basic one. So this thing on the inside, we can say that that's our g of x. So we can say that g of x is equal to 3x plus 2. And then we can also say that f of x, that's going to be our outer function, which is something to the 6th power, we're just going to say x to the 6th power. By the way, make sure that you do use x for both of these functions. Otherwise it gets really messy. So this is my answer. Let's go back and double check just to make sure everything's right. So let's check to make sure that f of g is actually equal to what we started with. So we said, again, this is our checking, by the way. We said that g was 3x plus 2. If we plug that into our f function right here, we get 3x plus 2 to the 6th power. So it does check out. That is what we started with. That's really all that you have to do on this problem. I do want to mention, though, that there are multiple answers for this. I just gave you the least complicated answer, so I'm going to tell you an example of an alternative answer. So an alternative answer is if you have something like 3x plus 2 squared for your g, and if you have something like x cubed for your x, believe it or not, that will actually give you the same answer as what you have here. The only thing is it's a little bit more complicated, so I recommend that you just use the easiest thing that you possibly can on these.